Uh, Welcome to Combinatorics. This topic is principles of counting, and under this topic, we will do counting. We will do counting. We will do counting of number of ways something can happen, a number of ways an event can occur, a number of ways we can arrange a thing, a word basically, a number of arrangement, number of permutations, so on. And basically we will do counting of the number of ways. So that's counting, and we will mainly have here two principles: addition principle and multiplication principle. And we'll also see like some examples or some applications of those principles. Okay, let's start. So first we have addition principle. Rather than explaining the principle, I have here a question like that gives you understanding of what addition principle is. So here's the question: Ram has 4 apples and Sam gives him 3 more. So Ram has 4 apples and Sam gives him 3 more, and Sam gives him 3 more. And now how many ways are there for Ram to choose any one apple to eat? So that means Ram has now 4 plus 3 equals to 7 apples. So among those 7 apples, how many ways will Ram have to choose any one apple? Obviously he will have 7 ways, he can choose any one of them. So answer is Ram will have 7 ways to choose any one apple, and that is principle of counting. Like if we have 2 sets and there are no intersections, then we add those 2 sets like we have done here. Ram has 4 apples and he got 3 more, so he has now 7 apples, and so he has 7 ways to choose any one of the apples he has. So this is principle of addition. And we have here another question, and this is also of understanding understanding the principles of counting. And here Ram has 11 A4 papers, so he has 11 A4 papers in total, and now 3 are of red color, 2 are of blue color, and 5 are of white color, and 1 is of yellow color. So the question is, how many ways are there for him to choose an A4 paper that is not of blue color? So not of blue color means like many of him will add these 3: red, white and yellow. So we get 5 plus 3 8 and 1 9. So we have 9 ways. So here we applied principle of addition. So we added these 3 and we got 9. So that means there are 9 ways to choose paper that is not of blue color. So that's right. But in combinatorics, generally what we do is like we subtract. We have 11 total ways, and there are 2 ways like we can choose blue. So we subtract 2 and we get 9. So basically, like if there were many red, white, yellow, green, pink and so on, so if there are many colors, and if we are asked that is not a blue color, then we don't generally add those all color and get answer. What we do is we have total and we subtract the number of ways we can choose blue, so that is 2, and we subtract 2, and 11 minus 2 is 9, so we get the answer. So basically this is quite helpful for combinatorics problems, and like this can also be done. It's also quite easy if there are like quite a few terms. Okay. So we go to next problem. So next problem is about multiplication principle. So before going to multiplication principle, I will do like some more problems on addition principle. So this is of addition principle, and and this brilliant.org, it's quite a like good place to practice and learn something. Like the problems here are quite of understanding level. They give us intuitive understanding and help us understand concepts and topic. So I also prefer brilliant for your practice. Okay, so we are going to do this problem here. This is also on principle of addition that we have just discussed, rule of sum, and this is a problem of counting. Okay. So a shopping mall has 3 parking lots. The first parking lot has 6 empty parking spaces, second has 80, and third has 310. If a car comes to the mall, how many choices are there for the car to park in a parking space? So you have got the answer, I believe. So the first parking lot has 6 spaces, and second has 80, and third has 310. So if we add these 3, we will get number of choices that this man has. So there's 390 and 6, 396. Okay. And so we got the correct answer. The answer is 396. We are going to the next problem. Okay. Next problem is about a pet has 12 green frogs, 10 black and white dogs, 8 brown cats, 7 green iguanas, and 11 yellow snakes. If you want a pet that is green or brown, how many choices do you have? So here, if we want a pet that is green or brown, so we can simply add those 2. So we have 7 iguanas and also 12 green frogs. So those are of green type, and for brown we have 8 brown cats, so we add 8. So now we have 12 plus 7, 19, and 8, 27. So our answer will be 27. 27. So we got the correct answer. The answer is 27. Okay, and now we do next problem. On a Calvin's street, each house is painted in a single color. There are 6 houses that are painted red, 9 houses are painted blue, and 12 are painted neither red neither blue. So how many houses are there in total? So we have information that 6 houses are painted red, and 9 are painted blue, and 12 are neither red neither blue, and we will just add them. We get 12 and 9, 21, and 6, 27. The answer is 27. So you get the correct answer. Okay. So now there are some more problems, but we have had enough practice, and I want you to try these like few more problems by yourself, and if there are any problems, you can share with us and we will help you. And now we go to principles of multiplication. Okay, and multiplication principle also we are going to learn by problems. So here is the problem. Ram has 4 shirts and 3 pants. Now tell me how many ways are there for Ram to dress. Okay, so he has 4 shirts and 3 pants. And how many ways are there for to dress? So he has 4 shirts. Short 1, short 2, short 3, and short 4. Like with every short he can choose any one of the 3 pants. So you can choose pant 1 or pant 2 or pant 3. Okay. So with sort 2 also you can choose any one of the 3 pants. With sort 3 also you can choose any one of 3 pants. And with sort 4 also you can choose any one of 3 pants. So what does that mean? So he has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 words. He has 3, 6, 9 and 12 words. So we got the answer 12. Okay. So but we can generalize this. So firstly he has 4 shorts, and with every short he can wear 3 pants. So there are 3 words with first short, and again 3 words with second short, and 3 words with third short, and 3 words with fourth short. So that just means that there are 4 into 3 words. Okay. So here what we can say is, if there are 4 number of first item, 3 number, like A number of first item, B number of second item, then if we just multiply A and B, we will get the number of ways they can be combined. So as we saw here, so with first 4 shorts we had 3 pants option for each of them, and so we got 3, 6, 9, 12, and we can generalize this as 4 and times 3, because for every one we have 3 items. So we multiply 4 by 3 and we got 12, and this is multiplication principle. Then I want to show you one definition from Google as well. One definition of multiplication principle. Okay. So what Google has to say is, the fundamental counting principle states that if there are p ways to do one thing and q ways to do another thing, then there are p times q ways to do both things. Possible outcomes of the experiment. Okay, and this can also be generalized. The counting principle can be extended to situations where you have more than 2 choices. So what does that mean is, if we have p ways for first thing, and q ways for second thing, and r ways for third thing, and s ways for fourth thing, then like number of ways, like we can how many pairs we had, like if we say that there are a p number of shorts, q number of pants, and r number of ties, and s number of shoes, the number of ways we can dress will be p into q into r into s. So we can generalize this for any number of terms, as the goal says, and we can also check it experimentally like I did earlier. Okay, so now we are in our PowerPoint. So what we can simply do here is 4 times 3 equals to 12. So we have 12 ways to dress. Okay, so now let's go to next slide. Okay, so I have 3 types of puffed rice and 5 types of instant noodles. Now tell me how many different types of chatpate can I make? So हामीसँग 3टा टाइपको भुजा छ, like भुजा 1, भुजा 2, bhuja 3, and with each type of bhuja, like we have 5 types of noodles that we can use. So with that I can either use noodle 1 or noodle 2 or noodle 3 or noodle 4 or noodle 5. With this bhuja as well I can use any of the one noodle, and with this as well I can use any one of the bhuja, any one of the noodle. So how many bhuja are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 ways. Or if I use the multiplication principle as I mentioned earlier, I can simply say 3 times 5 equals to, I have 15 choices. So by formally we do like this. So we leave blanks in, like first blank for bhuja and second blank is for noodle. So first blank can be filled by 3 ways, second blank can be filled by 5 ways. So when you multiply this, we have 15 ways to fill these blanks. Chutpate is basically when we fill the blank. So there are 15 ways we can fill the blank. We got it by multiplication principle and also experimentally. Okay, so our next question goes like this. So before this, I would like to go to brilliant.org and solve some problems from here, rule of product. First question isn't quite related with rule of product, like it's just of understanding. Okay, we will do this. So Calvin stays on the 7th floor in the building. Between each floor there are exactly 12 stairs. So this is for second, third, fourth, fifth, sixth. So Calvin is in 7th floor, and between each floor there are exactly 12 stairs. So here are 12 stairs, and if he starts from 4th floor and he climbs up to 7th floor, how many stairs does he climb? Here first, second, third, fourth, fifth, 2, 3, 4, 5. Like I have to draw one more. Okay. So 2, 3, 4, 5, 6. Okay. So this is first floor. This is second floor, third floor, fourth floor. Sorry. First floor, second floor, third floor, fourth floor, fifth floor, sixth floor, 7th floor. So he is in 7th floor, and there are exactly 12 stairs in between 2 floors. So that means that here are 12 stairs, 12 stairs, 12 stairs, 12 stairs, 12 stairs, 12 stairs. So there are 1, 2, 3, 4, 5, 6 times 12 stairs, and that is 72. And this problem was quite much of understanding rather than principle. So we type then 72. Submit. Yeah, we got the correct answer. Now, okay, so this question is of a multiplication principle. So Bernie's breakfast buffet has a wide section of breakfast food available. There are 8 types of cereal, 6 types of fruit, and 6 styles of cooked eggs. How many different ways can someone choose a breakfast consisting of 1 type of cereal, 1 piece of fruit, and 1 style of cooked eggs? So the breakfast cell consists of 3 blanks, and when we fill these 3 blanks, then we will get a complete breakfast. Okay, so first blank will be filled by a cereal, and second by a fruit, and third by egg. So we have 8 ways to fill first blank, 6 ways to fill second blank, and 6 ways to fill third blank. So by multiplication principle we can directly multiply, or we can also do experimentally by making those like arrow like figure I have made earlier. And so this will be 6 times 6, 36, and 36 times 2, 72, and then 144, and then 288. It will be 288. I will type it here and submit, and it's correct answer. And I will do one more problem and leave others for you. Our social team has t-shirts in 7 different colors and pants in 9 different colors. It's same like I just gave previously. And what is the total number of different uniform color combination for the team? So there are 2 blanks, and when these 2 blanks are filled, we will get a complete uniform. So first blank is for color, and second blank is it's a color, it's for t-shirt, and it's for pant. So t-shirt are of 7 different colors, and thus it can be filled in 7 different ways, and this can be filled in 9 different ways. So that means by multiplication principle we have 63 different ways. I shall type that 63 different ways, and the answer is correct. Remaining you can try it yourself, and if there are any problems you can always ask with us. Okay, so now we are back to our PowerPoint. So here the question goes like this: I have letters W, R, T, Y, and F with me. How many different 5-lettered words, both sensible and non-sensible, can I make if one letter can be used only once in a word? So do you understand the question? How many different 5-letter words can be made? Like the word need not have meaning, both sensible and non-sensible, and but one letter should be used only once. So that means we have 5 different blanks to fill, and if we fill this, then we will get a 5-letter word, because the word should have 5 letters. So all 5 blanks need to be filled. It can't be shorter than 5. And so, like in how many ways can the first blank be filled? So first blank can be filled by any of the letter, either W, R, T, Y, or F. So there are 5 ways for first blank to be filled. And how many ways the second blank? Are there 5 ways? No. किनकि one letter can be used only once. So हामीले एउटा प्रयोग गरिसकेपछि हामीसँग 4 बाँकी रहन्छ. And so if we use W here, so we have 4 ways to fill this blank. And now for this one, we have already used 2 letters, so we have only 3 ways. And now 3 letters are used, so we have only 2 ways to fill this blank. And we have only 1 way because 4 are used to fill this blank. And now how many words are possible? So here again, here is we use multiplication principle, and thus we get 5 for the 20, 60, 120. 120 ways are there for us to make different types of 5-letter words. Like if you want to do it experimentally as well, it's quite easy. Like W, R, T, Y, and F we can begin our word with any one of those letters. And with W, you can either use R or T, E, or Y, or F. And with R also we can use W, T, Y, F. Here also we can use W, R, Y, F. Here we can use W, R, T, and this is Y, F. And here also we can use W, R, T, Y. And again with each of them we can use 3 other words. Like if we have used W and R, then we can use T, Y, F. And again with this one we have 2 different possible words. And again we have this, with this we have 1 way. So we have 5 times 4 times 3 times 2 times 1. We can count this. With every 4 of them we have 3 different words, and every 3 of this we have 2 different words, and every 2 of this we have 1 different words. So that means we can count result, like it will take a long time though, but still we can simply like generalize the previous condition and we can get the answer 120. And if you disagree, you can count. Okay. So in maths what we do is like we just check if it satisfies for 2 letters, for 3 letters, and for like 4 letters, and then it satisfies for them. We like start to look for a pattern, like this pattern is followed. Like we can check up to 3 letters, and if that is followed, we like quite kind of believe that it's followed for every one of them, and we make a conjecture on that. And after a conjecture is made, there is a lot of discussion among scientific community until that is proved, and that gives us to beneficial results. So here it's not a conjecture, it's quite proved one. So we can do it for 3 letters, like if there are W, R and T only. So this is followed by R and T, this followed by W and T, and this followed by W and R, W and R. And so again this is followed by T, this is followed by R, this is followed by T, this is followed by W, this is followed by R, this is followed by W. So we can see we have 1 wedge, 2 wedge, our word can be WRT, our word can be WTR, it can be RWT, it can be RTW, it can be TWR, it can be TRW. So we have 6 words if we only have W, R and T with us. So if we had W, R and T only and not these 2, so we have 6 words. And by our principle as well, our question will be to fill these blanks. First can be filled by 3 words. Among these 3 words, any one word can be placed here. And we have placed, if we have placed one word, there will be 2 words. Like if we placed R, there will be 2 words only. And if we have placed 2 words already, this blank can be filled in only 1 way. So by principle of multiplication, we have 6 words. So that satisfies. And now we have to agree with me. Okay, so this has answer 120, and I already showed why, because it is 5 times 4, 5 times 4 times 3 times 2 times 1. Okay. And one interesting thing is that, like, we have a notation, like we have plus notation, we have minus notation. Okay, so we have a factorial notation. We have a factorial notation, and if we write 5 factorial, the factorial sign is same as exclamation mark. Aha, hooray भन्दाखेरि आउने sign हुन्छ नि, exclamation, बीचमा यदिबोधक चिन्ह. So it is same as that. And this 5 factorial, if we type in calculator, it will give 120. In Casio, like if we type 5 factorial, it will give 120, because 5 factorial means 5 times 4 times 3 times 2 times 1. So like if there is 10 factorial, it will multiply itself up to 10 times, 9 times, 8 times, up to 1. Okay, so if you know about the factorial, like it's simply the multiplication until it reaches up to 1. Like if there is 100 factorial, 100 times 99 times 98 times 97 times 96 times 95 times up to 3 times 2 times 1, up to it reaches 1. So basically we can define n factorial, like for any number n, like it will be n times n minus 1 times n minus 2 times n minus 3 up to it reaches 3 to 1, up to 1. So until it reaches 1, we will multiply, and this is 5 factorial. And if we know about this notation, like we needn't do calculation, we can simply write the answer as 5 factorial and done. So that reduces our effort. We can simply write 5 factorial and the answer will be right. So we proceed to next question. Okay, so I have letters W, R, T, Y and F with me, and how many different 5-letter words, both sensible and non-sensible, can be made if one letter can come more than once in a word. So again, same like previous one, we have 5 gaps to be filled to make a word. Okay, so we can fill first gap in 5 different ways, because there are 5 words, because there are 5 letters. Our first word can be filled in 5 different ways. And if one letter can come more than once, like we can repeat W again, because one letter can come more than once. So again for this also, like if we have used W here, we can again write W here. So we have again 5 different ways we can fill the second gap, and again we can repeat those W and Y. If we write here W and here Y, again we can repeat those. So we can, like, our word can be W, 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 and W. So we can have that word as well. So because repetition is allowed, and again we have 5 different ways because any of the word can come in this gap, and again 5 different ways because we can have any one of those words, and again 5. So by principle of multiplication, we can multiply this, and our answer will be 5 to the power 5, which is 5 times 5, 25. 25 times 25, 6 to 5, and 6 to 5 times 5, 6 to 5 times 5. I do have a calculator here. 6 to 5 times 5 is 3125. Okay. You can do this way as well. You can first 600 times 5 you can do, and again 25 times 5 you can do, and add those two. This will be 3000, and this will be 125. So our answer will be 3125, or simply 5 to the power 5. We can multiply these all, and we will get 3125, and that's our answer. Okay, and now I proceed to next slide. Okay. So I have letters W, R, T, Y, and F with me. This is basically a concept question, and I want you to try this before you watch how I solve. It checks your concept. And I have letters W, R, T, Y, and F with me. And how many different 5-letter words, both sensible and non-sensible, can I make such that at least one of the word is repeated? Do you get it? 5-letter words, but there at least one word is repeated. Like some hints for this question, I've already gave you. Like in one question of principle of addition, I gave there some hints about this problem. So then it will also use what we did in previous two problems. And so if words aren't allowed to repeat, then what did we get? There are 5 ways, 4 ways, 3 ways, 2 ways, 1 ways to fill the gap, and that gives us 120 words. So we can make 120 words without repeating any one of them. Okay, so these 120 words are made such that none of the words is repeated. Like I can't have W, W, R, T, Y among the words of among these 120 words. This isn't allowed. What we said, like first word couldn't be used, so there are 4 words, and those couldn't be used, so there are 3 words. So this 120 words just includes word like W, R, T, Y, F, and W, T, Y, R, F, or T, Y, F, R, W. So these words, we don't have any of the word repeated. They lie in these 120 words. So that means these 120 words are the words which don't have any of like letter repeated. And what we got, like if words are allowed to repeat, then the maximum number of words are, if they are allowed to repeat also, the maximum number of words that can be formed are, 5 times 5 times 5 times 5 times 5. So that is 3, 1, 2, 5. So like this 3, 1, 2, 5 like includes words such that every word can be repeated as well. Like this includes W, 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 W as well, R, 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 R as well, because there is no restriction here. Like any word can be repeated. And so okay, just cross this out. And so like these 120 words are the words without any letter repeated, and these 3125 words are the words such that any word can be repeated. There can be 2 words repeated, there can be W, W, T, Y, F, or RRTYF or anything of such. Like this can have all 5 repeated as well. And now what our question is. So now I will write this. There are 120 words without any repetition, and there are 3125 words with repetition. So such that at least one of the words repeated. So what is asked? At least one of the words repeated. Then we can use the concept of second question, because 3125 has all the words, either there are repetitions or not, that doesn't matter. This includes words like WRTYF as well, those with repetitions and without repetitions both. But this includes words without repetition. So if we do the subtraction, we will get 5003. Okay, we will get 3005, and these 3005 are the words that have at least one of the word repeated. Okay, so these are without repetition, with repetition, and these are the words with at least one of the word repeated. So we solved the question. It was same like the second one. So we did it, and I think it's over now. I think this is the last question. Okay, so end of slideshow. And like there are assessments on combinatorics. I complete those homeworks and have a happy learning. And if you have any problems, like, don't hesitate to ask.